Okay, so part two, we're going to continue tonight. We're going to do managing Cisco devices, which is chapter 16, and then IP services chapter 17. IP services, even though it says IP services, what it really means is what they call first hop redundant protocols. We'll talk about that in a second. We've talked about a lot of times single point of failure, single point of failure, single point of failure. What the first hop redundancy does is tries to do away with the single point of failure at the gateway. And we'll talk about those when we get there. The managing Cisco devices, we've looked at some of this earlier. This is kind of a little bit more. And when you read the chapter, he says, start in chapter 2, which means that this actually was chapter 2 in the consolidated book. But when they break it out into the ICD-10-1 and ICD-10-2, you start it, do a little bit of the overview because we talked about password resets and the boot process and those sorts of things. And we're going to do all of that again. So managing Cisco devices and the internal components of Cisco are the bootstrap, post, ROM monitor, and mini iOS are the things that we talk about there. And this is, I think this is the table that's in the book, or this is in the book. The bootstrap is stored in ROM. The post is stored in ROM. The ROM monitor mode is stored in ROM. ROM mon. At the end, I want to do a little demo on password recovery, and we'll go into ROM monitor mode in order to do that. And then in the mini iOS, smaller version of the iOS, Cisco calls it RX boot. So we have these things there. A lot of it is in ROM, the read-only memory. And the information, well, no, we'll go one at a time. And then we have RAM, the random access memory, and RAM is a volatile memory. Well, volatile means, you probably already know all of this, but RAM means that if we turn the device off, that everything that's stored in RAM goes away. ROM is a persistent memory, non-volatile memory, so that it holds the information. So RAM, it's got the packet buffers, the ARP cache, the things that we've looked at, routing tables, things that we've done. The running config, because remember, if we make changes in the configuration on the router and don't save it, and the system gets turned off or whatever, rebooted, power failure, then those configurations are gone. The upside to that is if you make a configuration and it doesn't work, all you got to do is turn the router off, turn it back on, and you get your old configuration back because you haven't saved it. I mean, it really is a way to try things out. If it doesn't work, just restart the router. The operating system is in RAM after it's loaded. It's going to be in flash memory, as you see down there in a little bit. It's going to be in flash memory for permanent storage. The ROM holds the mini iOS. The ROM holds a real basic operating system. And again, at the end, when we do the password recovery, you'll see those things. You'll see what it looks like. And it really does have an extremely small set of commands. And then an NVRAM, non-volatile RAM, holds the startup config file. The configuration registry, which we're going to look at in a few minutes, it says controls how the router boots up. It's got a hexadecimal code that tells the bootstrap basically where to look for specific things, or the boot process where to look for specific things like the iOS and the configuration file, where those things are going to be. So this is, and I think this is the one that is in the book, we have the major phases of the router boot process. So the first thing we're going to do is run the POST, the power on self-test, which all computers run. And a router as a computer is just a computer that has a specialized function, which is packet forwarding. So the post, the power on self-test, checks to be sure that certain hardwares are there and that they're functioning before it goes any farther. Once that happens, the bootstrap program that's stored in ROM is loaded. What the bootstrap basically does is loads the operating system. So the bootstrap looks for the iOS. It locates and loads the iOS. The iOS can be in Flash, can be on a TFTP server. We have the two locations here that it can be in. And when we look at the config register, it'll tell the system where to look for. The actual default, I believe, is first it looks in Flash, or excuse me, first it does a TFTP server, and then if it doesn't find that, it goes to Flash. Now that's not right. It looks for in Flash, then it looks for a TFTP server. If it then doesn't find an operating system, it goes into what's called ROM-MON mode, which is the real basic elements of it. You don't really ever want to be there. If you ever get in ROM-MON mode, it means there's something really drastically wrong with the router. After the iOS is loaded, checks to see if we have, it checks NVRAMs looking for the configuration file here. The configuration file, again, can be in NVRAM or can be in a TFTP server. If it doesn't find a configuration file, then it asks you if you want to go into setup mode. It will automatically ask you to go there. If you say no, then you go into user mode, and then you can go into enable mode and start your own configuration. If you haven't tried the setup, you should do it just to see what's there. There's nothing that you can do in setup mode that you guys can't already do. So Bootstrap looks for the configuration file. If it doesn't find it, asks you if you want to go into setup mode. This is a little bit more complex that I found on the internet. Flow chart of what goes on. So the ROM, and we turn the router on, the ROM initializes. And we talked about that first step. And then what is the configuration register boot field, 2 through F? And we'll look at those here in just a second. This one's not in your book. The router boots the boot image in ROM or boot flash. So it's going to get the basic elements here. And then depending on, and this is the numbers are there, whether it's a 1 or a 0 in this field. The image does not boot an image, but waits for commands at the ROM-MON prompt. If it is 0, and we'll look at these, the whole sequence, then it's going to go to ROM-MON mode. Otherwise, it's going to try to get the boot image in ROM or in the boot flash. If it's 2 through F, which is really what we're going to want it to be, and what we're going to want to see, I think, is 2102. We'll see it here in just a second. So 2 through F, are there any boot system commands in the configuration file? If it's yes, then it's going to use those. Those would be things that we would give commands. If the answer is no, which is going to be kind of the default situation, is there a valid image in the default flash device? So is there an iOS image in flash memory? If it's yes, the router loads it and you're ready to go. It is then going to go through the process of checking to see if there's a configuration file. If there is, it loads the startup config. If there's not, then it asks you if you want to go into setup mode. If it's not, we go no, the router tries to boot from the network using the default image name. This is the one that the network is going to be a TFTP, or actually you can configure an FTP server for this also. If the boot was successful, the router is ready to use. If it's no, the router boots the boot image in ROM or boot flash, and this is then down here going to get us into ROM-MON mode, which is ROM monitor mode. which is where you really don't want to be. And this is more the sequence. 1, the ROM goes through post, performs the post. 2, ROM, where it comes from the bootstrap, loads the bootstrap, and then Flash loads the iOS. Could also be a TFTP server if we configure the configuration register to do that. And then in NVRAM, we get the config file. Now, the configuration file, which is startup config, which is what we do, and the configuration register are different things. And with a lot of configuration here. This is the configuration file. The configuration register is up here that tells it where to look for the operating system. Well, again, there's going to be a slide here for that. So the ROM, we're going here, we're going to go into NVRAM, we're going to get the configuration. Could be from a TFTP server when we get those things. Or then we get into the console. But the configuration file, this is the startup config. Load configuration file, or enter setup mode if there is not a startup config file, and you've seen that before. This is the configuration register, which is a 2-byte 16-bit number. That's hexadecimal, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We do that. The standard here, 2102, is what you should see by default in these things. And if you go down here and look at the bit number 00 to 03, and we're going this way on the bit number, stays in the boot system, boots the system image on EEPROM if it is 002. So the EEPROM is flash memory. A lot of different things that we call these things, and it specifies the default, can specify the default net boot name. If we have in bit 06, and these are the bit numbers here, so if we go over here in bit 06 or bit 6 is turned on, then that tells it to ignore the NVRAM contents, to ignore the startup config file. 7, bit 7, disable boot messages. 8, disable break disabled. 10, IP broadcast all zeros. 5, 11, and 12 is a console line speed, but we have a number of these things that we can configure, and based on the bit number. The ones that you're really going to want to know are going to be the 2102, and then the one where we're going to set it, and I can't remember the numbers, going to set it so that it boots into ROM-MON mode. I was thinking that it would be, but it's not. 2402, I guess it's 2104. Anyhow, 00, if bit 0 through 3, 00, 2100 would be what it would be. Then we're going to boot to ROM-MON mode. 2101 is going to boot to the mini iOS. 2102 to 210F tells it to look to use the boot command specified in VRAM when we do these things. It is 2104 0024. It doesn't show 4 here, but what we're going to do, there's 2402. What we're going to do is tell it to ignore in VRAM. So what we're really going to do is change bit 6. I believe we'll see that when we get there. Yep, 2142. 2102, and these are the standards here. 2102 is the one that you look for. If we go back here to the configuration register, to change the configuration register to 2142, if the router supports it, and the router will, Packet Tracer does not support this command, so we have to go into ROM mon mode, and we'll do that. In order to do that, we change the bits, and on this one it's going to be 21124, so we'll put in bit 6, and bit 6 says ignore NVRAM comments. The reason we're going to do that for the password reset when we get there is we're going to start it up, and then we're going to get into enable mode, because we would not know the password. If you don't know the password, it's a pain in the rear, try to get in, because you can't. We're going to ignore the contents, get into enable mode, and then load the startup config file and change it. Again, I want to go through that. When you say it, it's kind of like, huh? But maybe when we go through the process, it'll make a little more sense. But what this one says is we do the config register 0x, and the 0x here means that it's a hex number. It's a hexadecimal number. And if we do the show version and the show version or show ver command at the end, and the output cut here means that there's a whole bunch of other information that's there, tells us what it is. And what it says is this is what it currently is, but when it reboots, this is what it's going to be. So when it reboots, it's going to ignore the NVRAM. It's going to ignore the startup config file. Boot system commands, these are the ones when earlier in the process it says it checks to see if there are any boot system commands. These are the ones that would be in the config file. The boot system, boot to flash, FTP, DECnet mop server, and I think he says that you can be like flash, FTP, TFTP, or some other worthless locations. Those are his words, not mine. Boot flash, and you notice when we boot flash, we have to tell it the name of the file, the binary file, the image that is going to boot. I did a great job of drawing it through them instead of underneath them. When you start doing these things, instead of trying to type them, if you show flash or show ver, you're probably going to get these things. Copy them and paste them. Copy and paste works just fine. Right-click copy and right-click paste.
So you got to write that
See this? Copy and paste it. Copy and paste it. Otherwise, unless you're a much better typist than I am, you're going to make a typo in it. So the boot system commands, we can boot, system config, host network. These are just some of the commands that are there. And then boot, if we do the boot system, we can either tell it to boot from flash or to boot ROM. And boot ROM, if you want it to again go into ROM mode. The password recovery, and these are the steps. And well, actually, we can do that right now when we do that. So what we're going to do is says boot the router and interrupt the boot by performing a break. You perform a break with the control break keys on the keyboard simultaneously. If you're using a laptop, since the break key is a function key, you have to do function control break. So when we do these things, we're going to change the configuration register to 2142, and that 2142 said to ignore NVRAM, right? So what we're going to do is to boot the router, and it's going to get to setup mode, and we're going to say no. So don't enter setup mode, enter the privilege mode and perform a copy start. So we're going to enable it, and then and then we'll get our pound sign, and then we're going to copy, and we're usually copy run start, right? In this case, we're going to go the other way around. We're going to copy the starting configuration file to the running configuration file. And then we're going to change the password, enable secret, whatever. Enable secret. Change the password. Reset the configuration register to 2102 so that it will then read the configuration file when you start up. uh, copy run start, reset the configuration file. Actually, we want to copy run start, and then we'll reset the configuration file, reload the router. So let me see if I can keep that. I have a packet tracer file here. Let me see.
So when you say change password, all we gotta do is en secret.
Yeah. Okay. Here we'll do en. We'll go through the process. This isn't the one that I wanted because it doesn't have a password on it. I've got one here with a password. No, I don't want to save my work. I want to get to my one with the password just to show you that there's one there. Packet files, and there should be one here. Password reset. As we wait and wait and wait. Can you see those any better? I can't make the, I wish I could make the text bigger on these things, but it does not work. So we'll go into this one, and it started up. And this one's asking for the password. Anybody know the password? I do, but I'm not going to tell you.
Password.
Password? We'll try password. That's always a good one, but that ain't it. Admin. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. The issue with Microsoft, with Cisco's, you know how long they are, and it doesn't give you any indication of what you're typing there, which is kind of a good thing and a bad thing. Huh? You think it's secret? Let's try secret. Oh, that didn't work. After you try it so many times, you notice here it says bad secrets, which means that the password didn't work. That's not it. It's none of those. It's none of the ones that we have used in them. So what we're going to do is go here and turn it off and turn it back on, because just the way this works, and we're going to do the break. And I'm now in the famous ROM-MON mode. And I think it's config register, right? Config reg, and we want 2142. You don't have to put hyphen in it. Yeah, you do. That's still not. Okay. What does he say the command is that I can't remember?
Check configuration default back.
I thought it was
CONF
REG, right?
Yeah. 0x.
Oh, it's all one command. I know you're supposed to do the 0x, and what that tells it is that it's a hexadecimal number. So I took it that way. Now we're going to do a reset. When we do the reset with the 2142, I almost did it right. I tried to do it on 2 lines, and it's a 1-line command. Now it said it didn't load the configuration file. Do we want to go into setup mode? And we're going to say no, because we don't want to go into setup mode. Now we can get right into enable mode, which we couldn't do before. But if I show run, I really don't have anything. So I can copy the startup config to the running config. Do I want to do that? Yeah, and now we'll show run, and here is my enable secret. Everybody can read that hash, right? Huh? So now what I can do, since I'm in enable mode, and I didn't have to type the password in even though there was one, I can go to config T and enable secret, okay? And now we can copy. No, we can't from here, can we? We do. Let's just get out of here. Now we can copy, run, start. And if we do disable and enable to ask for the password, and we made it secret, it works. So we've changed the password, reset the password. And you have to have physical access to these things. People say, "Oh, that's really easy." Say, "Okay, I want you to do that on that router that's sitting in Los Angeles. No remote. You can't do the control break. You have to be physically connected to it. You have to be connected to the console. And since this is the simulator, and when you do it, you have to actually be clicked into the CLI, the command line interface, the console of these things. So now, what I need to do, there is a config register file that I should be able to do from here. It's not programmed into Packet Tracer. So what I've got to do is go back and redo that other process again. And now we want to do a conf reg 2102, right? Well, that was 2102 is the one that, yeah, you got it right there. And let's do a reset. And it's starting up. The little pound sign says decompressing the image. The image files, the operating systems, are actually compressed in Flash, so it has to be decompressed, and that's what that thing's doing. So we press return to get started. It obviously did that for us, didn't it? Secret, and we're back in business. So we've recovered, reset the password, but you have to have physical access to the router to do it by modifying the configuration register. In the boot process, it reads it, and it's stored in VRAM. It reads the configuration register to see where it's supposed to find the operating system. If it's got a startup config file, we're supposed to find the startup config file, because you can store those things on one of the things it didn't do. You have to go back in. You notice these are down. You have to go back in and redo. Actually, I may not have had an IP address on it, but I thought I did. Do the no shutdown and put the or actually, maybe when I put the IP address on it, I didn't change it. I thought I had one on it, but it doesn't matter. But that's the way you do the passwords, the password reset on these things. So back to this process. If I can get back to mine. Back to this process here. We booted the router. We did all these things, right? I turn the pen back on too. Boot the router, and we interrupted the boot process. We did that. We changed the configuration register with the confreg. Thanks for the help, because I would have messed it up. 2142, and you really should put the 0x to tell it that's a hex number. We did, and then we reloaded the router with the reset command. We did not enter setup mode. We said no. We did enable, and then we copied start run to get the running or the startup configuration with the old password into the running configuration. We changed the password, copied. See, this reset the configuration register. The way we did it, you need to do the copy, run, start first, because we had to restart it. There is a config, but before you reload, be sure that you have saved what you just changed. Otherwise, you're going to do it all over again. Copying the iOS from a router to a TFTP host. We've done this. They're going to have you do it again. The topology that you have that I saved it's the same, basically the same one that you saw there for the password reset. And I think that I actually have IP addresses on the router. If not, it's 192.168.1.1, and the TFTP server is 192.168.1.2. And this is one that you've got to have to put this whole mess in. Instead of trying to type this, and trust me, I've tried to type this, and it says, I can't find it, about 14 times before I figured out that you can actually highlight it, right-click copy, and then paste it in there. So we're going to copy Flash, and Flash is where the iOS is stored to a TFTP server. If we're going to restore it or upgrade it, we copy TFTP to Flash. The thing you need to do before you start running, and there's some stuff down here, the TFTP server software must be running on a PC. What we're doing, It's a little bit more simplistic with packet tracer because all you got to do is go and say is that server's running. This is a TFTP server is a program that you go get. And the router, when it sends it to that service, and remember TFTP is a UDP, we'll try to do all these things, is a UDP program. It will send it there. It doesn't ask you for the directory, so you need to know where the default directory on that server is before you start sending things there so you can find them. They got to be on the same subnet. Ping it before you try to go. Be sure you have communication with it. And then we copy flash TFTP. If we're going the other way, copy TFTP flash. And then it will be a process. It's going to ask you what the name of it is, the name of the source, and the name of the destination, those sorts of things. And here's the other way around: copy TFTP flash. And again, you got to set this thing in, which is not always the easiest thing in the world to do. What's probably going to happen here is you're going to be on the same computer. You're going to have the TFTP server. You're going to be able to see it here. And you're going to be on a console in a DOS. So the TFTP server, you should be able to copy the name of it and paste it over here so that you don't have to, again, try to type it in. Been there, done that. It is a pain. And then if there is one, there's a file that's already there with the same name. What do you want to do? Do you want to overwrite it? Some of them will ask you if you want to delete everything. Be careful of that. Because if you delete the operating system, the first thing it does is delete it, and then the new one won't fit. Now you got a no operating system. The other thing that I would say to do before you do anything to this operating system is back it up. So that if all that other stuff doesn't work, you still got it. Remember, as long as the router's running, no harm, no foul. Unlike Windows, the entire iOS, the entire operating system is loaded into RAM. So as long as you don't turn the router off or reboot the router, you're golden. If it doesn't fit, copy the old operating system back in, but you've got to have backed it up. You should back these things up in the configuration files anyway, just in case something happens. The Cisco routers tend to all use the same commands, the same processes. So if your router dies and you have to get a new one, it's got a new operating system, or you got a new one that is not configured. If you have backed up your configuration file, all you have to do is use the TFTP and copy the back up the startup config to the router, restart the system, and you've got all your configurations. If you only have, like we have, 4, 5, 15 things, not a big deal. If you've got, 300, 400, 500 lines in the config file, you're probably going to want to keep it. So to back up the iOS, show version, and when you show the version, you're going to be able to see the name. And again, I think you want to copy it, and then when you copy flash TFTP and you go on down here, it's going to become a menu. It's going to ask, what's the source file name? So you paste it instead of trying to write it in, and then it goes on down. What's the destination IP address? You're going to need to know that. Be sure that you can actually ping this thing before you start. And then this says, what's the source? And it will take the name that you put in up here and make it the destination name so that it keeps that name. To restore it, copy TFTP flash the other way around. So it's always copy flash, copy source, and then destination. The Cisco file system, PWD, if you've had Linux, this is print working directory, prints it to the screen. It's the same command as the Windows dir directory if you want to see these things. So you can show some information about them. Let me see if I can get my packet tracer file, which I closed in the back. Yeah. And you can see you weren't always able to do that. You can see the directory structure on this thing. So if we go in here, and what we should be able to do is to do a dir. It has been saving it in different directories for me consistently all day long. Actually, I didn't ever save the file, did I? I just did a copy and closed it. Okay, so if we do a dir in the enable mode, then we can see what's in Flash. It says the directory of Flash, so we can see our operating system. And if you highlight it and right click it, copy it, and then if we wanted to do a copy Flash TFTP file name, and then I can go in here and paste that, and I don't have to worry about trying to get all the whole thing right, because they have really long. This one's actually short. This file name is short compared to what many of their file names are. So we can see the file system using either Windows commands or Linux commands. Depends on which system you're working on. Try to use the PWD on the Windows machine, and it doesn't take the Linux command, so you would have to have a Linux machine to do that. And what he talks about is the new iOS licensing system. Said that there may be questions on that. Prior to 15.0, 15.0 is the version of the iOS. So there were 8 different software feature sets for each hardware. And when you talk about feature set, what are you going to get in? Is it going to be a standard one? Is it going to be a security one? So you get different feature sets. It's now going to have a universal. What the universal image means is that all of them are combined in the same one. It's kind of like Windows has done. That you get one DVD to install Windows 10, and depending on which license you buy is which version you get, whether you get the full-blown or whether you get the basic one. So they've done the same thing here with this one. So you get one image and one feature set, which means you only have to download it one time, and you don't have to do as much upgrading of the iOS, because if you got a different feature set, it might be a standalone, or it might be an iOS that would replace the one you had. And when I talked about too large, sometimes if you got too many features in a router with not a whole lot of memory, then it wouldn't fit. And you deleted the iOS that's there, and then you couldn't get the other one in. So unless you had a copy of it, you couldn't get it back. But you got to unlock these things, and it's really kind of strange here. It says the licensing, 3 different technology packages available, and you can install them so that the additional features work. Provides the entry level. We have data, which is MPLS, ATM, and multi-protocol support. That's what we're typically going to use. Unified communications, VoIP. So if we're going to have a VoIP system, IP telephony, we're going to have that. And then security has got all of the security information on it. So the different functionalities are available. And it says if you need MPLS and IPsec, then you'll need to do the IP-based data and the security premium packages to unlock your router. When they do these things, to get a license, says you'll need a unique device identifier, which has 2 components, the product ID and the serial number that you're going to use. You get these from Cisco. You can get and I think it's in the slides, you can get a trial version, and they call it something else now. But you can get a trial version, and it says good for 60 days, and then when the trial version runs out, nothing happened because it's kind of on the honor system, and their licensing has been on the honor system for a long time. You just bought it, you had it. A lot of people were putting them up on the internet and sharing them. There is a software program out there called GNS3, which actually will run a Cisco operating system. So instead of using a simulator like Packet Tracer or Boson, you can run on your desktop. You can run the actual software, and it is the actual software. It's an emulator. A right to use, that's what I was trying to think of, which is basically a trial version. Original call to evaluation, the right to use are what you need to update your iOS to the new feature. But if you want to try it out, you can do that. Allows you to install the feature, and it says it's good for 60 days. To enable the right to use license, you use the license boot module just like you would if you had bought the license. The show commands, the show the license UDU, show the license, and these don't work on Packet Tracer. These are things that are just kind of there, and I think at the end of chapter questions asks a lot of them. There is an objective in ICND for licensing so that you know that there is a new licensing model when we do these things. So if you show the license UDI, the license install gives us the whole license file. The license save flash, and he names it toddlicense.lic so that the licenses are there. They will occasionally, when they start up, check. We had one time a firewall where the license actually expired on it after a year or two. I don't know if we did something to the hardware or if they actually had only licensed it for that long. But he does say in the book that if you use that right to use license for 60 days, after 60 days, nothing really happens. It's an honor system when you do those things. You want to take a break here for a minute?